Welcome back to ESPN. I am Steve Adams, and you are in for a good show tonight. Now, I'm going to throw it over to my friend, Mike Ruegger. Thanks, Steve. How's everyone doing? I'm Mike Ruegger, and today we have a special segment of Chemistry Craze called Aim, Shoot, Paint. The growing sport of paintball has taken the world by storm, but it is important to understand the chemistry behind this fantastic sport. So first, let's start with the making of the paintballs. So, paintballs, they are the individual projectiles which you fire out of the paintball gun. In order for these to be able to travel over large distances accurately and still splatter upon impact, they have to be made with a special process. And yup, you guessed it, that includes chemistry and solubility, one of our favorite things here on the show. The outer casing of paintball is gelatin, as you can see here in this diagram of a paintball. The outer part is gelatin, as I just previously said, and this is a material that is derived from connective tissue, which can commonly be found in things such as animal bones. And it's also used in other things, such as our jello that we may eat. This gelatin is used, it's almost as a bubble, which encapsulates the paint mixture which is inside. But the gelatin layer, while it has to make sure that it keeps it all in, it also has to be weak enough to still explode on impact. The paint mixture inside, as I have labeled here, is commonly many different substances, with the main one being polyethylene glycol, or as we're just going to call it for short now, PEG. So you're probably asking yourself, what the heck is PEG? Well, I'm going to tell you. PEG is a soluble in water, and it has no taste, no smell, and it will not deteriorate the gelatin shell. This is essential to the safety of each individual ball, as if it would deteriorate, it would cause the paint to leak out and it would become a faulty projectile. So, the fact that it is water soluble is also crucial, as it makes for an easy cleanup after a fun day out on the court with your boys. It is water soluble, as PEG is able to bond with the water, creating hydrogen bonds, which then makes for, again, as I previously said, an easy cleanup. This is similar for all the other substances which are used in the paint mixture, things such as dyes, other colorants, and even some type of sulfates. While these are part of the mixture, they aren't as prominent as the PEG is. So now you know how solubility affects the making of paintballs. So now that we understand how paintballs are made, let's look at the process of firing a gun. No, not that gun. Paintball guns I'm talking about here. But I promise you, it is just as cool. So, paintball guns, they fire with gas. Most commonly a form of compressed carbon dioxide, or for short, CO2. So, as you can see in this diagram here of a paintball gun, the gas is stored in a canister, commonly located here. And it is stored under a very high pressure, as it is just waiting to be released. And sometimes this pressure can be estimated to be about 800 psi. So, each trigger pull, trigger being here for those of you that may not know, releases the same amount of gas from the canister. So the gas goes here, and it's starting to make its way up here. So, and since it releases the same amount of gas each time, this controls the velocity as well as the accuracy of each shot, maintaining a similar baseline. So, as Boyle's law states, when the gas is released from the canister, it expands greatly. This is because it is no longer under the pressure of the tank, and thus the volume begins to increase. This is because Boyle states that volume and pressure are inversely proportional. So, as pressure decreases, the pressure from this, the volume will then increase because it is no longer in the canister, just to restate. This large expansion in volume then enters the barrel. So now it's right up in here, the gas is traveling here, and as it enters the barrel, there's just a lonely paintball waiting to be propelled. Woof! There goes the paintball, and it's all because of some good old chemistry. So, after discussing the process of making the paintballs, the shooting of the paintballs, the only thing left is finally hitting the target. So, after being shot out of the barrel, the paintball flies through the air and hopefully hits its target. At this point, it is traveling an average of 200 miles per hour. Just imagine how fast that is. On impact, the paintball hits with extreme force, and the gelatin shell bursts, splattering the target with paint. Again, this is related to the shell's ability to be water soluble and soft enough to break on impact. So, in order to become a more effective paintball player, there are ways to use chemistry to make your paintball gun better. First, it is crucial to ensure that you are buying high-quality paintballs, as they will perform better than low-end options. These commonly are well-rounded, there's no dimples, there's no seams, and they also have thinner shells than other options. These help to make the paintball have a more accurate flight path, as seams will create air friction, which will result in an unpredictable shot, something that no one wants. Also, thinner shells are lighter, which result in an increase in shot velocity as well as decreasing chances of a dud. A dud is a shot which hits the target, but it does not splatter on impact, rendering it basically useless. Also, another way to enhance your paintball gun is to upgrade the gas line, which carries the gas to the barrel. So a common upgrade is called a remote line. This is different than many stock options, and it allows the gas to expand at a quicker rate before entering the barrel. So this relates back to something we talked about before, Boyle's law. And if the gas is able to expand in volume faster, it will create more velocity. There are two ways that you can use. These are two ways that you can use chemistry to upgrade your paintball gun and make sure that you have a great time. Well, that's all for tonight, folks. It has been great diving into the chemistry of paintball with you, and hopefully you learned something new. Things to remember from today's episode would be the role that solubility played in the making of paintballs, as well as Boyle's law and how it relates to the mechanism of firing. So, I hope to see you next week on Chemistry Craze, and this is Mike Ruegger signing off.